So today's lesson, we're going to talk about characteristics of quadratic functions. And one of the things is to find the zero of a function. And the zero of a function happens to be an x value that's going to make the function equal to 0. The zero of the function also tends to be known as the x-intercept. And any quadratic function might have 2 zeros, 1 zero, or no zeros. Okay, and the zeros actually tend to be, when we were to solve quadratic equations, set the equation equal to 0, factor and solve, and we got those x values, those are the zeros. And now you'll see what they look like when they're on a graph. So there are 3 examples of the way you can find zeros from a graph. The first one, here's the quadratic equation given to you, but if you look at the actual graph, the parabola crosses the x-axis in 2 places. Those are considered to be your zeros. So the zeros here would be x equaling, on the left-hand side is going to be -1, and then x equaling on the right-hand side 2. So those are the 2 zeros. If you look at the next parabola, the next quadratic equation, the graph does not cross the x-axis at all. So in this case, there aren't any zeros. And if you look at the last one, that particular equation, the parabola does cross the x-axis in one place, which is right here, and this zero happens to be a +1. So the zeros happen to be where the graph crosses, if at all, the x-axis. There's also something that's called the axis of symmetry, and the axis of symmetry happens to be a vertical line that's going to divide the parabola into 2 symmetrical halves. The equation of this line is always going to be in the form of x equals something. Okay, so you got to figure out the x equals. Well, if you look at this first parabola, if I wanted to cut this thing smack down in the middle, I'd actually go right through there. And then the equation of the line is going to be x equals whatever that x value is on the x-axis. So the equation for the axis of symmetry here is going to be x equals, well, what's this point right here? This point happens to be -3. So the axis of symmetry looks kind of like a 0 setup, x equals, same idea, but that's what you're looking at. On the second graph, if I were to draw a vertical line down through the parabola to make it symmetrical on both halves, then the point right here on the x-axis is going to be my axis of symmetry. So in this case, x equals 1, and that's the equation of that highlighted line. If they ask you to find the axis of symmetry without giving you a graph, then there's a formula that you can use. So all quadratic functions are always in this setup. There shouldn't be anything new. Y equals ax squared plus bx plus c. But there's a formula that you can use to find the axis of symmetry. And that formula, because it's an x equals line, is going to be x equals -b over 2a. And you get the a and the b from the quadratic. So this is the formula that gets used when you're trying to find the axis of symmetry. Well, where's the b that you're looking for? It's whatever's attached to the x value. And where's the a? It's whatever's attached to the x squared term. So if we want to find the axis of symmetry of this particular graph, we need to be able to use the formula. So we need to identify the a and the b. So if we look for the a, well, the a is the value that's attached to the x squared term. In this case, a is 1. The b is the value attached to the x term. So b in this case equals 3. Again, you're just looking at what's happening in the given equation. There's your a, there's your b. So when you plug this into the formula, I always kind of do like a skeleton, x equals negative, open parentheses, over 2, open parentheses. So the b gets plugged in on the top, the a gets plugged in on the bottom. When you actually start doing the math, on top you get a -3, on the bottom you get a +2. And in this case, you really can't, well, you can make a decimal, but I prefer to keep the fraction. So the equation for the axis of symmetry is just this right here. X equals -3/2, and you're done. If we were to graph this particular parabola, we would see that if we wanted to draw a vertical line down the center of it, it would fall at -1.5, because again, -3/2, hopefully you realize it's just -1.5. Again, either one of these answers are fine. I like the fraction better. The next thing that you're going to be asked to do is to find the vertex of the parabola algebraically. You have done half of this already just by using the axis of symmetry, because believe it or not, the axis of symmetry is the x-coordinate of the vertex. So what you're going to be able to do, excuse me, is you're going to have to find the x-coordinate of the vertex, which is going to be done by using the axis of symmetry formula. Then you're going to find the corresponding y-coordinate, and you only do that just by substituting in the x-coordinate into the original function and solving for y. You basically evaluate the original equation by plugging in the x for the x. So you're going to be doing some substitution to find the y. And then the last thing is make sure that your answer is written as an ordered pair, because vertexes are ordered pairs. So your answer is going to end up looking something like this. The formula that you're going to use to find the x-coordinate is that x equals -b/2a, and then you're going to plug in for the y. So here's how this is going to work. And again, it's not too terribly difficult. You just got to take your time. Remember, the a and the b are what's attached to the x² term and the x term. So we should know that the a term is 5 and the b term is -10. Well, when we use the formula x equals -b/2a, the b is a -10, the a is a 5. When you do the math, double negatives give you +10. On the bottom, you get +10. So your x-coordinate happens to be 1. Okay, so what's happening now is your x value happens to be a 1. In order to find the y value, you need to go to your original equation, which is this. Y equals 5x² minus 10x plus 3. What's going in there is what the x value is, this value. So I'm going to put in a 1 for the x when I square it. I want to put a 1 for the x when I just multiply it by -10. And then you're going to do the math. Trying to extend this page a little bit. Okay. So then what happens is y is going to be equal to 5 times 1 squared. 5 times 1 squared is 5 times 1, which is 5, minus 10 times 1, minus 10, plus 3. When you keep going, 5 minus 10 is -5, and -5 plus 3 is -2. So then the vertex of this particular quadratic would be 1, -2. And you're done. Let's see if we can try this for the next one. Okay, so on the next one, our a value, this time the thing attached to x² is a -1. The b value, the thing attached to the x, is a -2. Don't forget that the equation for the axis of symmetry is -b over twice a. b is -2, a is -1. When you do the math, you get a +2 and a -2, top and bottom, which means the x-coordinate becomes a -1. That's your axis of symmetry, which is going to help you find your y value for your vertex. So then you do y equals -x² minus 2x. Remember, you need to plug in this x value wherever you see an x. It's going to go in here, it's going to go in here. So the x value is a -1. The x value is a -1. Be very careful when you do your algebra. You've got to square the -1 first. The square of -1 is 1. And then this really just becomes a -1 when you apply down that negative all the way through, right? And then -2 times -1 becomes +2. And this comes out to be a +1. So the vertex here says when x was -1, y was 1. And that's your final answer. Okay, so lots going on here. Being able to identify your zeros, being able to use the formula for the axis of symmetry to find the equation of that line, and then being able to use the axis of symmetry to help you find the vertex. All right, good luck tonight.